In this video we will see how to use the DICOM browsing functionality. First we will open a DICOM sample dataset. This is an example of a DICOM magnetic resonance image of the brain. So here at the right side we can see all the list of DICOM tags that are available for each of the DICOM slices. For example, for the first slice we can search for specific tags, for example the manufacturer or the modality. We can go to the next slide and we can play. So we can see all the DICOM slices that are available. Now we will open a second dataset. DICOM dataset is a DICOM RT. This is radiotherapy DICOM dataset. So the first series is a CT image, and we can also inspect the RT dose and the RT extract. If you go to RT extract, we can also visualize the different DICOM tags sequences. For example, this one is the structure set ROI sequence. We can see that it has 10 items. We open the first one, we can inspect the different DICOM tags, and if we also go to ROI control sequence, we can inspect the values of the different DICOM tag sequence. We can search. Okay, another interesting functionality is that we can configure and open DICOM datasets that are ordered in time. I will open another DICOM dataset example. This is an MRI image of the heart. So we can navigate through all the slices. We can play. As you can see, the DICOM heart is beating, but the problem is that the DICOM slices are not ordered, so all the DICOM slices are in the same time point, but in reality this DICOM dataset is divided in several time points. So how to configure this? The first thing we need to do is to search what is the DICOM time tag that is used for ordering this dataset. So one option is to show the different tags from one slice to the next one. So we will move to the first DICOM slice. We will see what are the DICOM tags that are different from one to the next one. So as you can see, one of the DICOM tags that could be possible DICOM tag used for the classification of the DICOM slices is the trigger time, because it's changing for each slice. But we also have an advanced option that will scan all the DICOM slices and will search for what is the best DICOM tag. So now in the combo box we can select two options. We will use the first one. We will visualize the value of this DICOM tag. We'll reload the DICOM dataset. Now all the DICOM slices will be ordered using this DICOM tag, and as you can see in the left side, we can see that the DICOM has been successfully loaded. Now we can inspect the DICOM dataset in time. You can see the heart beating, and we can inspect the DICOM dataset in space. So now we can also configure this manual configuration in an automatic way. So we need to go to the folder of the GIMIAS executable. This is the folder of GIMIAS. We go to the resource folder. We search for the DICOM tags XML file. We edit this file. This file contains all the configuration for all the all kind of manufacturers and modalities, and defines what is the time tag that will be used. So we will add a new entry for this dataset. So what will be the DICOM tags that will identify this dataset? So we will look for the modality, is the MRI, and what is the manufacturer is the GE Medical Systems. So we will configure this dataset in the configuration file. So we copy this GCT, we copy it and we rename it to GMR, and what will be the condition number 0 is the modality, is MR. The condition number 1 is the manufacturer, is the GE Medical Systems, and what will be the time tag that we will use. So this will be the time tag that we know that is working. So it's the 0018 and 1060. So what's the name of this tag? This is the trigger time. We add a comment here to say that this is the trigger time. What's the value? We add this name here also, so the trigger time. So now we will save the configuration. We can use the automatic mode to load this dataset. So the next time we open this dataset, it will be automatically loaded using this configuration. Once the dataset has been loaded, we can import this dataset in GIMIAS. So the data, we can use this data to process for processing. So this is the dataset we imported. Using the time management window, we can navigate through all the slices. You can see the harvesting, and we can search for a tool. For example, we can apply Gaussian blur filter. We select this filter, and we can apply the filter to the first DICOM slice. So we select the image, the output image. You can see the image has been processed correctly, but this image is only computed for the first time point. But if we want to compute for all the time points, we select all time points, we apply the filter, and we select the input image. Sorry, this is the first thing we need to do, is to select the input image. We apply it for all time steps, and we apply the filter. So now the filter is being applied for all the time points of the input image. Now we can hide the input data. So this is the output image. So this is the output image with the filter applied.